That was a lot. Can't say I enjoyed being abducted by aliens too much.
Man, that sucked. You were so cool in that shuttle heist, though.
Thank you so much. You weren't half bad yourself, you doofus. In any case, we're here for one reason and one reason only.
To get back
To
home?
make a science video!
We got abducted to make a science video?
No. That wasn't planned. Um, sure is handy though. Today we'll be talking about distances.
Like the distance between the sun and Caninus?
Yeah. Before we get started though, let's start with some more general terms.
Like, on the ground?
Yep. Let's start with the example of the eye now, shall we?
What do you mean by that, dear?
I'm talking about the delay in your eyes, you doofus. It's typically about 13 to 80 milliseconds, according to Ann Trafton at MIT.
Script here says to ask what this has to do with space, and I'm inclined to agree. I don't see the resemblance.
The resemblance here is the concept of delay. It's not caused by the same forces, though. It's caused by the speed the brain processes data. Just like how the speed of light causes the delay of visual imagery, everything you see happened in the past. How far away in the past depends on how far away it is.
This can be seen on the ground with airplanes and sound, or even lightning and thunder.
She's referring to how when an airplane goes faster than the speed of sound, which is quite, often back home, it causes a sonic boom. Bailey, pull up a picture of a sonic boom. Bailey, what is this?
You asked for a sonic boom.
Get that off the screen immediately, please.
You got it. Alright, is this image good?
Now I can demonstrate what we mean. What you're seeing is the air resistance from the aircraft moving at the speed of sound, or at least that's my interpretation of it. Regardless, it doesn't matter too much to the point. To the viewer on the ground, the sound takes a little bit to reach you, despite seeing it almost immediately.
Or, when you see a lightning bolt and the thunder takes a while to reach you. 7, 6, 5, 4, 3, 2, 1. There it is.
Even though you saw the lightning that caused the sound, it's still limited to the speed of sound. The same is true of stars. The distance of stars is so vast that the information that you see in the night sky is at the very least 4 years old, or even older. The furthest star we can see with our naked eye, in perfect conditions, to my knowledge, is the Rho Cassiopeia star at around 8,100 light years away from the planet Earth, according to Pete Lawrence of the BBC's Sky at Night magazine.
That means that the stars that you see in the sky have a range between 4 years and 8,100 years. Between the time it's been since high school and the beginning of civilization.
And it's certainly not because the speed of light is slow. The speed of light is around 300,000 kilometers per second. 300 million meters per second. Rather, it's that the distances are so vast that light takes that long to travel. Let's put the distances into perspective.
Our planet Caninus has a distance of about 1.13 Earth AU, circling around a yellow dwarf that is 1 solar mass. This is about 170 million kilometers. The speed of light is roughly 300,000 kilometers per second. This means the time it takes for even the speed of light to reach our planet from our own star is about 9.5 minutes.
Space is incredibly big. No one can even imagine the scale, even as we sail the stars in this warp ship.
Speaking of, since we're in this warp ship, let's talk about what this distance means. It means in the X-Cross galaxy, there's this star called KST 107c. It marks the halfway point of the place we just left, called Elron. It is 26,000 light years away from both Elron and the Caninus systems. That means it's only able to be seen using a giant telescope. Here's the thing though. About 50 years ago, it went supernova, and created a supernova remnant that neither Caninus telescopes nor Elronian telescopes have seen yet, and won't see for another 25,950 years. Since we took a starship, however, we're able to see the nebula from as little as 30 years in the past. As we traveled through the galaxy, it got brighter and then turned into this beautiful nebula, and we got to see this happen because we were close enough to see it as it was relatively recently. We forgot to take a picture of it, though, so, here's a picture of the Crab Nebula, which is a supernova remnant as well. And that's just galactic travel. Intergalactic travel is even further away. The closest galaxy from the Milky Way galaxy right now is the Andromeda Galaxy at about 2.5 million light years away. The observable universe is even larger, extending 46 billion light years in either direction, making it have a total diameter of 92 billion light years. But let's go back to the smaller scale. It would seem that we are about 452 light years from our home planet. We are? Awesome! That'll show what would happen if we point a really, really big telescope from it at that distance. Because the light takes 452 years to travel this far, we'll be able to see what kinds of ancient wonders happened 452 years ago. Let's see. It's 2087. So it'll be about 1635, right? Yep! Here we have this really big telescope. It's a magic telescope used for the purpose of this video to give a bit of insight of what you might see if you were able to see on the surface from this distance. Note that the orientation is a little off, but it works fine for our point. Here we go! Uh-huh. Yep. That doesn't inspire very much confidence. What did you see, dear? It's nothing. Don't worry about it. Okay, it's been a few hours, but we're coming up to Caninus. We hope y'all enjoyed the video and got something out of it. Beam us down, Scotty!